Alright, we're going to do our last one. We're going to prove that if the diagonals bisect each other, it's got to be a parallelogram. So basically everything that we found out is an attribute of a parallelogram. If given to us individually, right, then we know that it's a parallelogram. If the opposite sides are congruent, we know it's a parallelogram. If the opposite angles are congruent, we know it's a parallelogram. And now we're going to prove if the diagonals bisect each other, then we know it's a parallelogram. There's one other in there that we're going to list down below that we didn't actually do a proof on. But there's 4 situations that if you see a quadrilateral with one of these situations, then we know that it is a parallelogram. Anyway, let's go through this, right? They're going to give us that. Again, we're going to probably, if the diagonals bisect each other, we're going to try to show it's a parallelogram. I'm showing up here that the diagonals bisect each other, like AE and EC, which is right here, and DE and EB, which is right here, and that is our given, right? Angle AEB, right, this one right here is congruent to CED, this one right here, and AED here is congruent to this. Well, wow, we haven't used that in a while. Vertical angles, all right? So if you look at it, we can prove a bunch of triangles congruent. We can prove this triangle congruent to this by side, angle, side, right? Side, angle, side. And we can prove the left and right triangle. So let's do it. We're going to say triangle AEB is congruent to triangle CED. And also triangle, let's do the right. So we'll go BEC. BEC is congruent to triangle DEA. DEA, and that is side, angle, side. That's our SAS. And once we get that, we can prove the parts of those triangles. So AB, it's got to be congruent to CD because they're corresponding parts of these top and bottom congruent triangles. And AD over here, 1, 2, 3, 4, is going to be congruent to BC because they're also corresponding parts. So CPCTC. And then we've already proven that if the opposite sides are congruent, then it's a parallelogram, which is what you're going to write here. If both pairs of opposite sides are congruent, then it is a parallelogram. I'm going to pause here to let you write that down. And we're going to use it. Well, I think I lied to you. I think there's one more we got to get through. Maybe a little tiny bit more. So, yeah, we're going to keep moving here. Alright. So here we go. Here are the 4 that we've done. Opposite sides are congruent, then it's a parallelogram. Right? Opposite side is congruent and parallel, then it's a parallelogram. That's one we didn't really prove, we just listed at the bottom of the first page. If opposite angles are congruent, then it's a parallelogram. And if the diagonals bisect each other, this last one we just did, then it's a parallelogram. So let's see if we can prove that it's a parallelogram down here. If you need to pause and write those down, I'm cool, but I'm going to keep going. So this has one bisected diagonal, and that's not what it says. It says diagonal, so we're going to say no. This one has 2 sets, right? This diagonal bisects that diagonal. That's our rule 4, so we're going to say yes if the diagonals bisect each other. This has one set of opposite parallel sides, which was the one we didn't do a proof on, but is listed on the bottom page, so that's yes. And this has consecutive congruence, so that's really a trapezoid, not a parallelogram, so we're going to say no. Alright. I want to read this, and just because it's on this page, and we're going to look at the next page, but I'm going to just read this right now. Sometimes properties of one type of geometric figure can be used to recognize properties of another geometric figure. Recall that when you explored triangles, you found the medians of the triangles are congruent at a point 2/3 of the distance from the vertex from the midpoint of the opposite side. You can prove this theorem using one of the conditions of parallelograms in this lesson. We're going to skip this because that was a construction we never did. I probably should have written it out of this note. And so what that ends up meaning is that we actually aren't going to do this page. So I'm going to say no on this page, and we're going to go to the last page here for our final video, which I'm going to make right now. I will talk to you soon.